Hi Hannah. Before I answer this question, just want to remind you of one thing. The indices rule that says if you've got something like that, that gives you 2 to the power of 15. 3 times 5 is 15. And that's true if you've got a number, but it's also true with algebra. So that would be x to the power of 8. Because this is 2 to the power of 3 times 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 2 to the power of 3. If you add up all those 3's, you get 15. And this is x to the power of 4 times x to the power of 4, which gives you x to the power of 8. So that's the rule you need to bear in mind to answer this question. And the trick with this question is realising that 16 and 8 can be written as powers of 2. 16 is 2 to the power of 4. So I can rewrite this as that. That's 8 is 2 to the power of 3, so I can rewrite this as that. Okay, now using this rule, that becomes 2 to the power of 4 fifths, and there's no expectation for us to work that out, we're okay. And this becomes 2 to the power of 3 times 3 quarters is 9 quarters. I could write that as 2 1/4, but I'm just going to write it as 9 quarters. Now, what I'm going to do now is use the other rule that says when you multiply powers of the same thing, you add the indices. So this makes, it looks a bit odd, but that's going to give me that. I've just added 4 fifths and x. Now, I've got 2 to the power of something here equals 2 to the power of something here. So what that must mean is that these two things must be the same. And that means that x must be 9 quarters take away 4 fifths. Now, on a non-calculator paper, I'd be going for a common denominator, but I don't need to worry about that, do I? I can just say, okay, I'm on calculator paper, so I'm just going to go 9 quarters take away 4 fifths, and that gives me my value of x, which I could write, sorry, across the page, I could write as 1 and 9/20. Hope that's okay.